recording. So Sadi, you can take it away.
Cool, thanks. Hi everyone, thanks for having me. I'm a recent graduate, of the tech stream here at Daniels, and just a little bit about me. I was also a former vice president of ALD. So it's great to be back. In this tutorial, we'll be going over sort of a quick introduction into Grasshopper, and then we'll go over your homework week 2 tower. So we'll just start right away. This is Rhino. So you're all very familiar with the Rhino interface, and Grasshopper is a sort of like a plugin that's built into Rhino, and it allows you to create sort of do more with the geometries in Rhino in a parametric way. So to get to Grasshopper, you just type in Grasshopper in the command bar and hit enter. When it opens for you, there might be some sort of like blocks here with tutorials and previously opened files. We don't need to really worry about that for us. When you open up Grasshopper, you can sort of double click anywhere to start working right away. And the difference is, so what I'll do first is actually dock the Grasshopper window, not full screen, but just to the side here. That way you can still see your Rhino viewport where all of the geometry will still appear, but you will be working inside Grasshopper, which is this window here. So right off the bat, the top view, so we'll just start from the top of this window and just work through like what each of these things mean. So you have file where you can sort of create a new document or open an existing document. You also have one of the key tabs here is the view bar, which will sort of allow you to turn on the plugin, the component bar, which is this here. So all of the Grasshopper components that we will be using today are, they live here. So to get that, just make sure Canvas toolbar is turned on, as well as the component tabs. So that's basically Grasshopper. This tab here, we'll get to in a bit when we start creating some geometry. So inside Rhino, we can create geometry by using these commands here, these buttons that allow us to create blocks, as well as spheres or any other sort of geometry like that. And you can select it here, and you can maybe modify it by selecting each individual face and then sort of manipulating it in a way. You can also do this inside Grasshopper, but in a more powerful and parametric way. So to create this rectangle inside Grasshopper, what we can do is, first of all, look for the rectangle component, which is this one here. So that brings in this this block. This is a component. Every component, almost every component, will have an input side, which are these blocks right here, as well as an output side. And one way to sort of preview blocks and components better is if you go into display, make sure draw icons is turned off. For you, it might look like this. And in the beginning, this is not so useful because you won't know what you're looking at just from the icon itself. So if you go into display and turn off draw icons, you will see the full name of that component, and then you can search for it better. If you go into display, you can also turn on draw full names, which will basically expand the inputs and outputs. So you better understand what the component is asking for and what it's outputting. So we'll leave that on like that. So when you brought this component in, it's sort of, you might not see anything because this block here is actually hiding it. So we'll just get rid of this block. We don't need it anymore. And right away, you'll see this red sort of thing appear. And if you click on it, it highlights in green. So that's already creating a rectangle here. It's hard to see, but there's a rectangle that's 2 meters by 1 meter. The Grasshopper units are the same as your Rhino units, and in this case, it's in meters for us. So to create let's say a cube that's 10 meters by 10 meters by 10 meters, we'll start with the rectangle, which is the base, and we're going to set the X size and the Y size, which are the X and Y dimensions. And the plane, don't worry too much about it. Right now, it's set to the XY plane, which is just the origin. We can also set optionally a radius for the rectangle. So to create dimensions, we'll need to create, give it values, right? And to do that, we can use a new component called number sliders. So just type in number slider, and it's this one right here. You can double click on that number slider to bring on this menu that gives you more options to set the minimum, the maximum, as well as some sort of precision values here. So we'll set this number slider to be between 0 and 10, let's say. So I'll just set that max value to 10, and then I'll just hit OK. So this slider now goes from 0 to 10. I can copy this for X and Y. So we can just right away connect these components together. And now we can sort of see that rectangle that we were sort of working with, and we can change it. Next, what we need to do is extrude this rectangle up in order to create our cube. So to do that, we're going to use the extrude component. So we'll just search for extrude. It's this one right here. You can also find these components from the component tab, which lives on top of your Grasshopper window. And what this needs, right away, it's orange because it's basically saying that there is nothing, you're giving me nothing, I can't do anything. So input parameter base and direction, that's the two things we need to give it. So the base is basically the base geometry for your cube, which is going to be this rectangle here. So I'll just take that rectangle and plug it into that. It's still orange because it needs a direction. And for us, the direction will be in the Z direction. So if you type in unit, there's a few vectors, which are sort of your cardinal vectors, and they're the same as Rhino. So Z is up and down. We'll need that. And the factor is basically how many meters do you want to move it up or down by. And in our case, we'll just duplicate this slider again. An easy way to duplicate a slider is while you've selected it and you're dragging it around, if you press Alt once, it'll create this sort of ghosted view, and that's a copy of your slider or any component. So we'll connect that to our unit Z and then connect that to the direction. And that gives us this cube, but it's not quite done yet because it's missing the top and bottom. And to finish it off, we can just type in cap holes. That's another component, and connect that. And finally, we have our cube, which is the same as Rhino. But the more powerful thing about doing our cube this way, first of all, you'll notice that there's quite a few more steps in creating that simple cube that we created in Rhino. But the power of this is that these sliders are now very easily controllable. You can change these around, and your cube will update live without you having to sort of select and then drag those around. So it's very parametric. Now, what you'll see in Rhino is like this cube you can't select it. So even though you see the geometry inside Rhino and you can move around it, it exists in Grasshopper and it doesn't quite exist in Rhino yet. So you can have a project where you're using both Rhino geometry, like cubes and spheres, as well as Grasshopper geometry. So I'll just create a little sphere here. And maybe sometimes you want to hide your Grasshopper geometry because it's getting in the way of your Rhino work. Well, you can do that with the items in this top right corner of your this bar here. So the first option is to basically completely hide anything in your Grasshopper. So if you click this, it will hide anything in Grasshopper and you won't see it. The middle option is to draw just a wireframe, so it makes it easier to see, but you won't see anything shaded. And obviously, of course, the third option is what we had before, which is just the preview. So if you ever like lose your script and you just can't see it in Rhino anymore, just make sure that this is set to shaded geometry or wireframe. Next up, we have draw a preview boundary. So what this does is it allows you to draw basically a shape around a component, and it will only show that component. So right now it's hiding everything else, just showing me the rectangle. And if I just press escape, that comes out of that. One more is so you can also just choose to draw selected component. So if I just select the rectangle, I can see just the rectangle. If I select the extrude, I'll have the extrude without the cap. And finally, this is just the full cube with everything included. Finally, this component, this last option is to basically change your preview settings globally. So you remember that if we select a component, it highlights in green in Rhino. And if you just leave it, it's red. So you can change these colors around. The last option is just for quality. Just if your Grasshopper is causing your Rhino viewport to lag, just set this to low quality. Yeah, that's about it for getting used to the preview. One more thing. So I'm just going to turn off the draw only preview. So I deselected that, and I'll make sure it's doing shaded geometry. So we drew this cube, but there's also some additional geometry that's like showing up here that was actually this rectangle. So it's showing all the steps that we did. But sometimes we don't want to see that. So what you can do, and you can do this with any component, is if you right click on the component name, you can turn off its preview. So if you click on that, it becomes this gray color. Now you can't see that in Rhino anymore. There's another way to do this is if you just middle mouse click on the component, there's these icons here, and this one is to enable preview and this one is to hide preview. You can also disable a component. So that will make it so that that component is basically doesn't exist. So it's this button here, or you can right click and click on enabled. And what this will do is almost like, yeah, it'll disable the component so it doesn't output anything. And now these components here are orange because it's saying that the input base, so the geometry, it failed to collect data. So it's, yeah, so just if you're, the use case for this is if you're debugging some part of your script and there's another part that is very heavy and time consuming, you can disable that temporarily while you figure out what's wrong with your script, or if you want to preview something. So we'll re-enable that. Also with the middle mouse button, you can find that here. And that's basically how you create a simple cube. Very basic introduction to Grasshopper. Yeah, so this canvas is where you work. You can put your components anywhere, really. It doesn't have to be inside the canvas. You can move around. If you press the middle mouse, there's going to be certain, like a few options. Right now, some of these are grayed out because I didn't middle mouse on top of a component. But if I were to select the component and then put the middle mouse, some certain additional components show up as well. And now, so I'll just go back to not selecting anything in middle mouse. So there's these options here, like that'll help you navigate really long scripts. So, you know, you can like sort of drag a window around your screen. If you're like really zoomed in, you can sort of move this around your whole script. And there's some other things like you can find components by searching for them. So that's about it for the UI, the Grasshopper interface. So you can find your components here. Everything we search for, they can be found there. And yeah, that's about it. Does anybody have any questions about the Grasshopper interface or just anything super basic? Nope. Great. So now we'll move on to creating the sample tower, which is part of your exercise 2 or week 2 assignment, which is where we're going to create this shape using the graph mapper component and a series component. So I'll just show you what that looks like and in Grasshopper. So it looks like that. I'm just going to delete all of the Rhino geometry. And yeah, this is all that is in this script. We'll go over this very detailed, so just don't worry. So I'll create a new document in Grasshopper by going to File and New Document. And we'll start with basically where we're going to place our tower. And the way we're going to do that is to create a point in Rhino. So using the point tool, I'm just going to place a point anywhere in Rhino. And then what you can do is you can bring that point into Grasshopper by using any one of these parameters, these geometry. Well, actually, for points, there's a specific component that you need to use. For everything else, there's a specific component. So for circles, planes, lines, breps, which are solids, some of the components you can bring in with geometry. Like a lot of things can fit in a geometry. For example, you can bring in a point with geometry and it will highlight that. But it's better to use the component that is more specific to what you're bringing in. So for example, in this case, we're just going to use point. So I just brought it in from the command bar. Alternatively, you can search for it, and it's this one here. And then if you right click on this, you can set one point. So we'll click that and we'll click on this point. And now if I hide this point, it's no longer visible or selectable in Rhino, but I can still select it and see it in Grasshopper. So it's now referenced inside Grasshopper. What I'm going to do here is create an ellipse to start off our tower. So the ellipse is basically, there's dimensions for it here. It's got a diameter, one diameter of 20 meters and the other is 30 meters. So to create an ellipse, I can search up ellipse, and there's quite a few, but this is the most simple one. And what it needs is a plane and 2 radii to create that ellipse. So we're going to give it a plane. We can just simply pass in this point, and this will be where that ellipse starts. Already you can kind of see a really tiny ellipse forming. That's because there are already values set in the radii, and you can sort of see that if you hover over it. So in the x direction, it's 1, and the y direction is 1. So it's creating a circle right now. But we're going to give it our own numbers. So we'll create 2 sliders. So number slider, double click that, and we'll say we'll say this goes up to, let's say, 50 meters in case. We'll set the value to 30 later. And we don't need 3 digits of precision, so we're just going to put that to 1 and say, okay. So now we'll just double click on this slider and put in 30, and we'll duplicate this slider, put this to 15. So it's 30 meters by 20 meters actually. But this is actually asking for the radius, and we have the diameters. So we'll just divide everything by 2 and pass those into the input of the ellipse. So that creates the ellipse that we're looking for. I'm just going to zoom in there and move this so it's easier to see. Cool. Yeah, so we have our ellipse. Now, the next thing we're going to do is array it upwards to form our floor plates. To do that, we need the move component. So we'll type in move, bring that in. We'll also need, so the move component requires the geometry. What are we moving? And it's this ellipse. So we'll connect this ellipse to the geometry. And the motion is the direction and how many moves are we doing to get it there. So the direction is obviously unit z, because we're going in the z direction. If you did unit x, it would go basically towards the right. If you did y, it would go into the screen. So z is up and downs, which is what we need. And we'll connect that right there. But now we need to give it the amount and how many to move up by. To do that, we're going to use a series component, which is this right here. And this requires the start number, the step size, and the count. So how many numbers will there be? And if you search for the panel component, this is a very useful component for debugging and just understanding how components work and what they output. You can also just do a double slash and hit enter, and that will create a panel. So if we connect the output of our series right away, what you'll see is it's giving us a series of numbers that start at 0 and end at 9. So there's actually 10 numbers here, if you include 0, because 0 is part of the list. So if we hover over the start, it's set to 0, which makes sense because it starts at 0. The step size is 1, which means it's incrementing by 1 every time. And the count is set to, if I just hover over that, 10. So there are 10 values. So in our case, we need to move up by like however many floors we have. And the amount that we move up by, the step size, will be the floor height, the distance between each floor. So we're given that. So the distance between each floor is 3 meters, and there are 50 floors. So we'll create 2 sliders. An easy, quick shortcut way to create a slider is to first put in your lower limit. So it's going to be 0 for us. Then put in a less than sign, and then put in your upper limit. And in our case, since we have 50 floors max, I'm just going to put in 50. And that creates a slider that goes from 0 to 50. So we'll connect that to the count because that's how many floors we want. And for our step size, that's going to be another slider. That's going to be the floor height. So that's going to be, again, 0. And then this time to 3. Connect that to step. And already you can see that it starts at 0, 3, 6, 9. It just goes up until 147 meters, which is how tall this tower will be. So we'll connect that right away to the factor, and already we can kind of see the tower forming, but it doesn't have the iconic twist yet. And we're going to get there by using a new component. This one's called rotate, and it's right here. Also can be found here. And this one takes in 3 different things. So it, again, takes in the geometry, which is what you're going to move. It takes in the angle in radians. We can also just right click and set this to degrees, and you'll have this icon here, which means it's in degrees now. And it also takes in the rotation plane. So where are we rotating from? So we know that we're rotating the geometry, each of these curves, right? And if we connect the panel, we'll see that there's basically going to be 50 elliptical curves. So we'll connect that to geometry. And now there's a bunch of stuff on my screen. I'm just going to hide this because we no longer need that. We're okay with just seeing this. So the plane, we need to set the center of rotation to be the center of each of these floor planes. Right now, the plane is actually this origin. So if you rotate, it's going to rotate around this origin, which is not what we want. So we're going to use the area component, which is this one right here, to feed in our geometry. And we're not really concerned with the area of our floor plates. We just want the centroid, which is the center point. We'll connect that to plane, and that'll fix that. No need to do anything more there. Now for our angles, we're going to use a few components, namely the series component, to get a series of angles, as well as a new component. This one's called Grasshopper. This is one of the requirements of your homework, which is to use the Grasshopper component and the series component to control the rotation, to create this sort of effect. Because right now what you can see is it sort of starts off not rotating much up until the middle, and then it sort of does a 180, and then it continues to keep that rotation and not rotate much. And we can achieve that through the Grasshopper. So if you right-click the Grasshopper, there are certain graph types. We're going to use the Bezier. There's quite a few, but this one is the one we need. So we're going to drag this. Actually, we'll leave it like this for now. We're going to connect the series component first. So this will be, again, the start, step, and count. And the series component will actually connect to the input of the Grasshopper. So the Grasshopper, it's basically a function. If you imagine it's got a X range and a Y range. So the X range goes from 0 to 1, and the Y range goes from also 0 to 1. So we need to, for every X value, it's going to give us a Y value. To make this work, we need to give it a series of X values that are basically 50 X values, because that's how many floors we have. So we'll actually just start connecting things right away. We have a slider here that controls how many floors we have. So we'll just connect that to count. The start can be 0. It'll start at 0. It'll have 50 numbers in it, but the step size has to be something really small so that it adds up to 1. And to do that, we're just going to do some basic math. I'll create a panel and then just put the number 1 in there, make it really small. Then I'll bring in the divide component, and it might be sort of hard to find it if you just search for a divide, but if you just type in a single slash, it's going to give that to you much quicker. So we're going to divide 1 by how many items there are. So that'll give you a really small number, like 0.02. And then this is going to be our step size. So every time it goes up by that much. So if you look at this series now, it starts at 0 and it goes up really small until it reaches 0.98. So just 0.2 away from 1. Then we'll connect this to the Grasshopper. So just make this a bit neater by moving things around. Like here. So now let's connect the output of our Grasshopper. So it gives us a series of numbers. These ideally would be the amount you would rotate the floor plate, each floor plate by, to get that sort of interesting rotation. So right now, like, I would connect this to the angle, but it's not going to do much because these values for angles are incredibly small. They're all less than 1. So it is doing something. It's just impossible to see. And you can kind of see if you move this, numbers are changing. But what we're going to do now is remap these numbers that go from 0 to 1 into like angles in degrees. So the angles in degrees would be 0 to 180. So we can do that with the remap component, which is this one, remap numbers. And it takes in the value, the source domain, and the target domain. So I'm just going to ask you guys, like, what is the value? What are we trying to remap, and where do we get it from? Does anybody know the answer to that?
I guess we could use the Grasshopper.
Yes, exactly. So we're going to take these values from the Grasshopper, and to get the domain of the Grasshopper, we can use another component called bounds, which is this one right here, and we'll connect that as well. And this will be the source domain. Now for our target domain, we're going to create it. So I'll bring in a new component called construct domain. And it's not the domain squared one, it's just this one, construct domain. It's going to have just the domain start, domain end. We'll connect that there. Now the domain start is basically where the start angle, which is in our case going to be 0. So I'll create a number slider actually that goes between 0 and 180. So 0 is going to be the start because that's where we'll say this angle is. It's at 0. Connect that to start. And then we'll duplicate this slider and set it to 180. And this is going to be the final, like the end angle, like the last one. So if you look at this, if you sort of follow each floor plate, it's rotating almost, it's rotating at 180 degrees. So we'll connect that to the domain end. And that's about, yeah. So now we have the remapped values. Where do we connect this to? I'll give you a hint. I'm selecting it right now. Yeah, so I'll just go ahead and do it. So we had this connected to the angle before. That was before it was remapped. It was very small, but now we can just map this directly to it. And now we can already kind of see it's working. It's hard to see because they're all lines, but there is a twist happening, and it's like controlled by this slider. So trust me on this. It's not too hard to see, but I mean, it is actually not too easy to see. It's very hard to see, but we're going to do a few more steps to make it easier to see. Namely, we're just going to add floor plates thickness. So right now it says that each floor plate is 0.32 meters thick. I'm going to add some more thickness to it, but what we're going to do next is take these geometries and extrude them up. So to do that, can anybody name like what component I would use to extrude curves? Yeah, good job, Dan. It's extrude. So if you search up extrude, there's quite a few extrudes, but we're going to be using this one. And it requires a base geometry and a direction, similar to the move component. So the base geometry is going to be our curves, and the direction, we're going to extrude in the Z direction. So we'll type in unit Z, connect that to the input, and already it's sort of starting to extrude. And just to see things better, instead of using the 0.32 meters, I'm just going to connect the factor to the floor height, which is in this slider here. So 3 meters, I'm just going to drag that into the factor. And yeah, so that extrudes all of these for us, and it sort of becomes easier to see that there is a twist indeed happening. And you can control that where that twist happens by moving the slider around. So just by changing this graph, you can control how smooth that transition is. So if you make it completely straight, it's sort of twisting like almost linearly. But if you were to change this shape, maybe like this, it sort of, changes how fast and where that twist happens. So that's about it for the tutorial, for the workshop and your part 1 of your homework. Now I'll just go over any questions. And before I do that, actually, I'll just go over one more thing about Grasshopper, which is that you can connect multiple wires into the same input. And there really wasn't any use case here for us to do that. But for example, if you were to loft, which is another component and a command between geometries, let's say we had, yeah, there's some other components as well. I don't have time today to go over them, actually. This is just really an introduction to the user interface of Grasshopper and just going over your assignment. So maybe I won't go over that, but if anybody has any questions, let's just go over questions now.